Alright, let's do the solution for our lab 1. So I'm going to create a new class, and I'm going to call this lab 1. Lab 1. Okay, so there were 3 parts to this. One was a write a function that returns, or that takes a value n and returns the sum of 1 to n. Okay, so let's write this one out here. Just need a function, public static, and if we are returning, then we want a return type of int, and we will call this sum, and we're going to take a value n. Okay, and so if we're going to add numbers 1 to n, well, then we need a for loop, right? For, so we start at 1. So we start at 1. We go until I is less than or equal to n, so we're going to include n, and we add 1 each time, right? And this is an integer. Okay, so every time we go through this loop, we need to add that value I to our sum. So we need a variable integer sum, but we need to initialize it to 0. Now inside a loop, we can do sum equals sum plus I. And once we are done, we're going to return sum. So this should do it, right? So I'm going to say here, let's call this, we're going to say integer, actually I can just say sysout. I'm going to call sum, and then we'll say 5. Or any number we would want. Run this here, and there we go, 5. And 4, and so forth. So we can even kind of debug this as we go along, right? We can say sysout, we can say I, and then add concatenate sum. So we kind of see the progression as we go along. So if we run this now, they're adding 1, 2, 3. We see we're adding each of the numbers beforehand. And to make this even more clear, we can say sysout. We're saying I. We're saying actually sum. Then we'll say plus concatenate plus I. And then we will say print sum. Okay. Put that on the same line. Here we go. This should, let's see. We'll say equals, there we go. 0 plus 1 is 1, because sum is 0. I is 1, 1 and 2. 1 is the sum, 1 add 2, you get 3, 3 and 3 is 6, 6 and 4 is 10. So there we go. There is our summing integers 1 to n. Okay, our next one was writing a function that computes the factorial. So, write a function that computes factorial, and then I said hint, use recursion, which is what we implemented with the Fibonacci. Okay, so the factorial is public static, again int, we're going to return a value, and we're going to call it factorial, and again we're just going to take a number n. So here's our declaration. Okay, so the rule of factorial is if n is equal to 0, then we're going to say the factorial of 0 is 1. Okay, that's our basic rule. Okay, otherwise, what we're going to do is we're going to return the factorial of n minus 1 times n. Right? So that's what factorial is. It's n times n minus 1 factorial. Again, if you don't recall what this is, I have it in the assignment where n equals n times n minus 1 factorial. Right? So what is that? That's basically n times n minus 1 times n minus 2 factorial, which is, again, n times n minus 1 times n minus 2 times n minus 3 and dot dot. etc. So in other words, every time we're going to have an n, we need to find the factorial of the n minus 1. And so that's what is happening here. We're going to continually call n minus 1 until we get to 0, which is 1 itself. Okay, so now we can say we're going to print factorial of, let's say, 6. Or let's do 5, because I know factorial of 5 is 120, so this should print out 120. Here we go. So we'll say factorial. There we go. Very good. Okay, and again, if we want to kind of show how this goes, we can just print out sys out n, right? And so this is going to show all the values of n that's going to be multiplied out. So if we run this here, so there we go, 5, 4, 3, 2, 1. So in other words, we are then calling each of these numbers, it's going through each of these numbers and actually multiplying those out based on this recursive formula right here. I'll talk about recursion a little bit more later when we get into algorithms, but just so you kind of get some familiarity with how to do recursion, this is we are continually calling n minus 1 until we get, of course, to 0. Okay, the last assignment was write 3 functions that return the min, average, and max of an array. Okay, so let's come right here. We'll do public static. Okay, so let's do the first one, min. And again, if we are going to return, then we don't want to do void. We want to do int. So we'll call this int. Call it find min. We're going to take an array like this. Okay, now if we're going to find the minimum, we need to compare it to something. So there's a couple ways of doing this. You don't want to set that something to 0. You might want to say, let's say our integer min is the array at any index. Let's say it's at 0, right? Because we can have negative numbers. We can have an array of all negative numbers. So let's just set it to the first index. In fact, let's define our array up here first. We'll say integer numbers equals, let's just give it a bunch of numbers here. Okay, just a random set of numbers. Okay, so what we want to do is let's just assume that the first number is the minimum. Okay, now what we're going to do, we're going to iterate through the entire array, doing for integer I equals 0, I less than array.length, I plus plus. And then the simple step here is going to be if the array at I is less than min, right? Put this inside parentheses here. If it's less than the min, then we're going to reassign the min to the array at I. And then finally we're going to return I once we get out of that loop. So again, it's going to go through each loop, or each iteration here. We don't want to return I, we want to return min. And it's just going to say, is this less than the min? Is this less than the min? Is this less than min? And if so, we're going to reassign that new value as the minimum. So we can say print minimum is numbers. We're going to call find min and pass the numbers array. There we go. So this is just going to return a number, right? And let's run it. There we go. Minimum 438. That looks right to us. Okay, good. Okay, to find the max, so I'm just going to copy this down because it's basically the same. And I'm going to change this to find max, right? And now I'm going to change this to the max. I'm going to assume that the max is at 0. And then I'm going to say if the array at I is greater than the max, then I'm going to assign max to that variable or that item. And we're going to return max, and once again we're going to print max is find max at numbers. You can do this all within one function, but my assignment was to do 3 different functions. Run it there. There we go, 234, and that looks right. Okay. Now finally we want to find the average. So push that down, public static find average. And once again, we're going to take a array. Okay, so to find the average, we need to take sum and divide by number of elements, right? So what's that process going to be like? First, we need to have essentially this right here, right? We found the sum of numbers 1 to n. Instead of doing 1 to n, we need to do 1 through the, or not 1, we need to do the elements of 1 to n. So that's going to look like this: for integer I equals I. So we're going to have our counter, and this could be anything, right? This could be n equals 0, n less than the array dot length n plus plus. So hopefully you're getting familiar with how to write these for loops, right? So we're initializing a variable, we're telling the duration of that loop, and then this is our incrementation, which is n equals n plus 1. This is typically how, this is a very common setup for a for loop, where you're going to go through the entire set of the array. Okay, so what we want to do then is we need our variable for sum, right? Sum, we need to initialize it to 0. And then we're going to say sum equals sum plus what? Sum plus the value of the array at I. And then we're going to return sum. Not at I. We're doing n for this, right? We're doing n for this loop. Okay? Then we're going to print sum is find, actually it's not sum, it's average. Okay, so we're finding the average. What is it? It's the sum divided by what? Right, sum divided by number of elements. Number of elements can be found by the array dot length, right? And so, in fact, let's print out the sum and say sum. There we go. And now we're going to find the average, which is find average. We're passing numbers. Okay. Let's see. Why is it not liking that? Oh, we need to have the return type. So we're going to return an int. There we go. Okay, so we print this, or we run this now. Okay, so our factorial, we have our min, max. The sum of all the numbers is actually negative 138, and that's because this 438 is so large. And then we have our average of 23, which is 138 divided by 1, 2, 3, 4, 5, 6. And that looks about right. 138 divided by 6 is 23. Okay, so that's our assignment, right? We had a function that takes values 1 to n, a function that computes the factorial, and we wrote 3 functions that return the min, max, and average values.